E a gente começa a programação com o painel Computação de Alta Performance e Inteligência Artificial, que será o primeiro momento Tendências de hoje. E quem vem ao palco para compor este painel é Aoun Bunshaft, vice-presidente da DASSAULT Systems, e também Joseph Aoun, presidente da Northeastern University. Sejam bem-vindos. A palavra está com Aoun Bunshaft.
Thank you. Good morning, everyone, and thank you for joining us. It's my pleasure to be here with you this morning. I hope you saw some of the event yesterday. I was here, and I thought it was an outstanding event. I have a few minutes this morning to talk with you about a project called The Living Heart. Yesterday, you may have heard the GE executive here talk about a digital twin of a steam turbine. And what I'm going to talk to you about is the first ever digital twin, virtual twin of the human heart. It's both a physical, electrical, and fluids model of the human heart. And I think it's a very innovative use of modeling and simulation, and it will give you a strong understanding for where modeling and simulation technology is taking the future of healthcare. Our company, DASSAULT Systems, is a leader in innovation. We've been recognized now many years in a row by Fortune magazine for being one of the most innovative companies in the world. We focus on 12 industries. You may or may not know of our company. We're a leader in computer-aided design with software such as SolidWorks and CATIA. 100% of the commercial aircraft in the world are designed using our software. Yesterday, you heard many examples of innovation. You saw a robotics factory at Tesla. Tesla is another example. The entire electric vehicle industry is using our software. Tesla is designing, simulating, validating, manufacturing their products using DASSAULT Systems software. You heard about Waymo, Google's electric autonomous vehicle initiative. They're also using our software. But today, I want to talk to you about healthcare. Why? Because we're taking the same technology we've used in other industries, and we're using that technology now, moving into new industries, such as simulating urban infrastructure, and in this case, talking about the future of medicine and the personalization of medicine. I've been at DASSAULT Systems 7 years. I worked in other technologies previously, and I want to draw your attention to the very right side of this chart, because I think one thing that sets us apart is we are very long-term driven. We're in our 4th decade as a company. We have a 10-year vision, and we talk now about creating 3D universes, virtual universes, 3D experience universes that allow our clients to imagine, create, simulate products before anything exists in the physical world. This is our CEO, and he talks about how our mission is to create 3D experience universes that allow clients to imagine sustainable innovations that harmonize product, nature, and life. And that's very significant because for most of our 37 years, we have focused on product, primarily mechanical engineering type of applications. Yet we see how now we can take that same capability into many other industries, not only simulating the products in their environment, hence nature, but also beginning to simulate life. Why do we use, for example, crash test dummies in the automotive industry? We do it because we can't yet fully simulate the human body. Well, that's changing, and I'm going to show you how that's changing in one specific area. So for many years, we've done applications like this. BMW crashes all of their vehicles thousands of times using Abacus, our structural analysis software, in order to optimize the design prior to building any physical models. But what if we could take this same technology and apply it in new areas? What if we could take this same realistic simulation technology and apply it in new industries? That is the motivation for the Living Heart project. So why the heart? Heart disease is by far the #1 cause of death and dying, not only in the United States, which shows those statistics, but also here in Brazil. It's a very significant cost to our economy. It's a very significant impact on our productivity and our lifespan. Not only that, we found working with manufacturers that the large majority of devices implanted in the heart are actually never simulated or tested with humans. And so in many cases, we're going by trial and error in many of these areas. That chart threw me off. That wasn't in my presentation. So one of the challenges in the medical industry is there's a tremendous amount of research. As you can imagine, billions of dollars is poured into the science of healthcare. But one of the challenges is that many of these projects occur in isolation. Many very interesting projects go on, many very provocative breakthroughs happening in the research domain, but very often those breakthroughs are not translated into practice. And so one of the things we thought about was we want to do more than only build a model for academic use, for research use. We want that model to be able to be used in practice by cardiologists who can then take these heart models and use it with you, the patient, or me, the patient. Use it working with device manufacturers. Allow device manufacturers to use that same model to validate their products prior to the introduction of the products. So we thought a lot about not only what we could do, but how do we join forces with the right parts of academia, research, industry, government to translate this breakthrough ultimately into practice in the field of medicine. And so the mission of the Living Heart Project is to help advance the development of safe and effective cardiovascular products and treatments, uniting the engineering field, the scientific field, the biomedical experts to validate and then critically important to translate this technology to deliver improved patient care. We want to do more than only deliver interesting research. So how did we go about this? This project is now approximately 3.5 years old. And we began by starting with a very simple model of the human heart. We developed from there more sophisticated models. So we began, for example, with a simple materials model. We have many materials that we model in our business. For example, carbon fiber composites are striated types of fibrous materials, but then we had to go work with physicians to understand how to build a human heart tissue model, to model the musculature of the pump that is our human heart. We then started with very simple electrical activation and over time increased the sophistication of the electrical network model that we use to model the heart. And finally, the fluid flow of the heart. After we built these individual models working with experts, we were then able to take these models, these physics models, and couple the physical model to the electrical model to the fluid model in order to couple these physics together and then to, again, work with the industry and with the experts in the field to validate this model of the human heart. Starting from very simple, going to a precise model of the heart tissue, the electrical network, and the fluid flow that occurs. Remember, I said one of the critical goals is to translate this research into practice. And so it was very important for us to build a consortium, a collaboration of players from around the world. And so you see here many of those organizations that have been involved in the Human Heart Project. It starts with researchers from all around the world who are the leaders in cardiac healthcare-related research. In fact, Professor Costa from the University in Brasilia, here in Brazil, is a member of this collaboration. We're then working with industry, in particular with the medical device industry. Our focus of this heart is to apply it in the implanted device industry, so stents and valves and implanted heart devices. And so all of the major players in the medical device field are members of this consortium. We then also involved clinical cardiologists, practicing physicians in the field of cardiology, and finally, the regulators. The Food and Drug Administration in the United States. We have been working for many years with them on digital verification and validation of both devices and drugs, but in particular devices. We want to shorten the time frame to put new devices into the marketplace by using digital validation and verification as well as living trials. And finally, the Medical Device Industry Consortium is a member of this. And so we have researchers, we have practicing doctors, we have the industry, and we have the Food and Drug Administration who are validating these devices. So what kind of benefits have been derived from the living heart? The living heart is now being used in many fields and in many areas. First of all, it's being used for devices. It can lower the development time and the development cost of delivering new devices to the industry. It can allow us to personalize treatments. So, for example, if you saw the process of building the living heart model, it begins with scans. It begins with CT scans and MRIs, and we can import not only a scan of the heart, but we can import the scan of your heart or my heart, the patient's heart. And we can use that for doctors to better understand treatments and to explain those treatments to their patients. We can use it for diagnostics, for doctors to better understand and interpret images. You know, most doctors today use 2D images, which are slices of the heart. We've constructed a full 3D animation of the heart that doctors can view in real time. Doctors can slice using virtual and augmented reality technology. I'll show you some images of that. And doctors can work directly with patients and educate them. In fact, what I brought with me today to show you, I'm sorry I didn't get a chance to take it out, is a 3D print of a human heart. So this is an example of a heart of an actual patient with a defect. And actually this one is somewhat old. We have much better models and more precise models today. But this is what can happen. So my doctor can print a model of my heart and sit down with me and talk to me about what's wrong, what he plans to do, what the options are that he may have evaluated, and why he's recommending a certain path of treatment for me. What we also see is we're working with a company called Biomodics who is printing implanted devices for doctors to better understand the implant procedures. So for example, I've learned a little, I'm not a doctor, I'm not a cardiologist, I'm a computer scientist and an engineer, but I've learned a little bit about these implanted devices, and in fact, today we mostly have standard size parts, small, medium, and large, for example. And when a valve must be implanted, the fit of that valve is critical to the success of the implantation. And very often those valves are inserted through the leg, and looking at a scan, the doctor then has to place the valve in the patient's heart. Using the 3D printed heart and the valves, doctors can now understand the fit, the sizing of the valve, prior to attempting to place the valve in the patient. So there are many examples of stents and valve implantations where this new tool, the living heart model, can be used in many different ways for the device manufacturers, for the doctor, and for the patient. And ultimately, what we imagine, what we fully expect, and what these device manufacturers are doing is that in the future, this will be completely personalized. And so when you need a valve replacement, that valve will be created for your heart and your valve specifically and your size, and reducing the risk, because one of the significant causes of death in a valve implantation is when the valve becomes unseated. If the valve is not fit properly or there's a leak around that valve, it can be a very significant problem for the patient. So there's quite substantial advances that are possible using a model such as this. So here you can see some of the examples of uses today for this living heart model. In the upper left quadrant, you see a stent, and the doctor's evaluating the placement and expansion of the stent into the position. On the bottom left quadrant, this is a doctor looking at a stress model of the heart based on a valve ring that's being implanted and trying to understand if it's putting unnatural stress in one part of the heart or another. And then in the bottom right, even being used for biological treatments today. I never even gave them this chart. I don't know where they got it. And the chart is, my last chart is missing. Can you back up one chart, please? So what I wanted to, the next to last chart you should see is one of the different modalities that we have created for visualization. We have both a virtual reality environment where doctors can go into a cave environment and understand surgical procedures by experiencing them in virtual reality. We have an augmented reality environment using a display called a Z-Space, which I apologize, you should be seeing. And the heart components can be seen in 3D and manipulated in 3D by a doctor or a medical device company. And I encourage you to visit. We have a display in the Expo Center where you can see and learn more. My final chart also, my final two charts are apparently not there. The final chart shows you the address where you can learn more about this Living Heart project at our website. Please search on DASSAULT Systems and the Living Heart, and you can see some videos, see the virtual and augmented reality technology in action. I was unable to show it to you here today, but I hope what I've introduced to you has given you some idea for how some of this very advanced computing technology that's used in traditional mechanical engineering type of domains is working with the right experts from healthcare and from bioengineering. We're bringing this same technology into the world of medicine and healthcare, driving personalization over time and driving new techniques that are truly going to transform healthcare. We already have interest after working on the heart project now and working on the brain, and we can easily imagine how organ by organ we'll be able to model and simulate different parts of the body. And it's a very, very exciting space to be in. And if you're in that space, the future is very bright. And we're excited about how this technology will transform healthcare. So I thank you for your attention.
Thank you, Al. Thank you, Lee. Thank you, Al. Thank you. Good morning. Al took away the heart, and I'm going to talk about the human heart now, since you talked about the artificial heart.
No, please.
So good morning, everyone. 1,000 years ago, the agricultural revolution moved us from foragers to farmers. And hundreds of years ago, the industrial revolution moved us from farmers to factory workers. And 30 years ago, the digital revolution moved us from factory workers to knowledge workers. And now we are in the midst of the artificial intelligence revolution. What will be the impact of this revolution on us? We are seeing intelligent systems, we are seeing robots becoming much more efficient, smart, at mimicking many things that humans do. what will be the impact of the intelligence revolution, the artificial intelligence revolution on us? It is not clear. What is clear to us is that we want to stay employed and we want to have meaningful jobs. And unless we educate ourselves for the jobs of tomorrow, we are going to become obsolete, we are going to see jobs disappearing, and we are going to see social disruptions. Why am I raising the alarm bell? Because artificial intelligence is colorblind. It made many blue-collar jobs obsolete, more to come. You are hearing about self-driving cars. That's only the beginning. But also, as I mentioned, they are colorblind in the sense that they are making white-collar jobs obsolete. As we speak, intelligent systems can read and create contracts, can pick stocks better than a stock picker. They can even predict the onset, the beginning of type 2 diabetes in individuals. And machines are becoming much more sophisticated. The implications have been studied extensively. There are studies made by McKinsey, by Accenture, by Oxford University, and by other outfits, predicting that in the advanced economies, in the next 20 years, nearly half of the jobs we know, at all levels, are going to disappear. The World Bank just published a report showing that in the emerging economies, in the next 20 years, 70% of the jobs that we know are going to disappear. That's enormous. The impact is going to be enormous on all of us. So what are we going to do? What is our responsibility? In higher education, there is a great wake-up call that is needed, because we must educate people for the jobs that only humans can do. And we must make ourselves robot-proof. So it is good to take a minute to ask ourselves, what is setting us apart from machines? It's not computational power. Machines are much better than us at computational power. What sets us apart is the ability to innovate, the ability to create, the ability to have a human heart, to empathize with people, the ability to work with people, the ability to dream big, and think the impossible. So the human frontiers are not going to be in processing. You can expect and predict that every job that is based on processing it will be automated and will be impacted. Therefore, we need a model of education that is relevant for the 21st century. We need a model that will make learners, students, robot-proof. It's easier said than done. How are we going to achieve that? Well, I'm going to talk about two types of learners. The traditional learners, 18 to 22, that every country focuses on. And those learners are short on experience and somewhat long on time. Short on experience, long on time. Usually, universities have them for 4 years, 3 years, 5 years, depending. worldwide, and essentially they educate them. But so far our education has been built on silos. We educate them to be engineers, to be accountants, to be computer scientists, and there is nothing wrong with that. However, we are keeping them in their lane. Clearly, we are in a situation where we want every learner to become, little by little, robot-proof. So how are we going to achieve it? Well, clearly, we need to focus on their skills. We need to focus on their technical knowledge. But beyond that, it is necessary for every learner to master what I call the new literacy. What is the new literacy? The new literacy involves knowing about technology. Coding is going to be ubiquitous. You are seeing more and more students coming to college, to universities, from high schools knowing coding. You need to have an understanding of the languages of the machine. You also need to understand how to take the output of the machines and make sense of it. You heard yesterday more and more about big data. That's what I call data literacy. So every learner has to master and understand technology, coding, and whatever else. Every learner has to master the output of technology, how to make sense of the data that is being generated, of the results that are being generated. Those are the sine qua nons, the basics. But beyond that, we have to focus with every learner, no matter what she is learning or what he is learning, on what I call the humanics, namely the properties that are essential and unique to humans. The ability to create, the ability to be innovative, the ability to dream big, the ability to work with other people, the ability to be culturally agile across cultures and throughout the world, and the ability to empathize, the ability to be ethical, the ability to be entrepreneurial. I have not met a computer that is entrepreneurial, that will send people to Mars and bring them back. Those are the attributes that we need to focus on. It's not enough to stay in our lane and to say we are happy that we trained educators, that we trained engineers. We need to get them to focus on the implications of what they do. We need to get them to think the unthinkable. It's easier said than done. How are we going to achieve it? We're going to achieve it through experiential education. What is experiential education? Experiential education is immersing, is putting the learners in real-life situations, in companies, in NGOs, in order to understand the world and integrate it into the learning model. The world is too interesting to ignore, and that is why you are seeing that universities have been divorced more and more from reality. And that's dangerous. My colleague and friend Eduardo Padron, the president of Miami-Dade, was telling me yesterday yesterday he heard very few companies saying that they have agreements with universities and partnerships with universities. But universities are the source of talent, and the pipeline of innovation and new ideas. It goes both ways, but we have a responsibility as educators to bring back the connections and the partnerships. Yes, we divorced ourselves as educators from the real world, and the real world divorced itself from us. And that's the opportunity. Experiential education is going to force us to send our students in real-world environments and bring back what they have learned into the classroom. So we need to integrate the world experience with the classroom experience. And that's, for instance, what my universities do. We have an extensive co-op model. It's called, those are long-term internships. We have 3,000 companies in 146 countries, including Brazil. As we speak, we have students doing those co-ops or long-term internships in Brazil and bringing that back to the classroom. So what I said so far is that higher education has to integrate the skills with the humanics, what makes us different as human beings. And we believe that this will be the first step in getting you to be robot-proof. However, no one is robot-proof for life. When I went to college, when I went to the university, they said to me, you get a bachelor's degree or a master's degree or a PhD, and you're set for life. It's no longer the case. Why? Because machines are getting smarter. And therefore, the limits of machines are expanding. And which means that there are new jobs being created and more jobs becoming obsolete. And therefore, we have to move into lifelong learning. Every one of us will have to retool, whether we want to stay in our jobs or we want to move to other jobs. And this is the opportunity and this is the challenge. Why? Because higher education, in general, has not incorporated lifelong learning as part of its core mission. Our mission has been to educate the 18 to 22 or, more extensively, people for a BA degree, and to do research. But what about lifelong learning? You say it's easy, we can integrate lifelong learning. Well, it's more difficult than you think. Because when you start being really willing to provide lifelong learning, you have to shed many things that we do. Let me give you an example. If I tell somebody in the workplace, an executive in the workplace, now you have to move, to understand cybersecurity or data analytics, big data, come back and spend 2 years with us, they will look at you and say, what are you talking about? I don't have time for that. So time is an issue. If we tell them, come back to the university, I don't have the opportunity to travel to your university and be embedded with you, even if it's for a short period. So lifelong learning is going to force universities to be there and provide learning on demand, which means that we have to provide learning to the learner wherever they are and whenever they need it and however they need it, which means that we have to move into personalization. We have to provide personalized education. We also have to provide customized education. We have to be embedded in companies, and that's what we are doing now. We have created a network of various partnerships with companies ranging from GE to Amazon to Cisco, where we are, to IBM, where we are providing the education there, based on their time and based on their needs. So this notion, come back and spend 2 years or even a year, is obsolete. We have to provide boot camps, we have to provide certificates, we have to provide stackable certificates, and we have to provide outcomes. So you see, what I am saying today is that universities have to move into lifelong learning. Otherwise, we ourselves risk to become obsolete. Many of you represent companies. We are seeing more and more companies setting up what they call universities. What does it mean? It's a failure of our university system to provide their needs, to meet their needs. Education is not their core business. They tell us that constantly. And why are they doing this? Because we are not meeting their needs. So there is an enormous opportunity for higher education to provide the needs of people who are in the workplace, or what I call people who are long on experience, short on time. As a matter of fact, in my country, in the United States, 68% of the learners are now non-traditional learners in the workplace. So you see the shift, and that's the opportunity for higher education. In order to become robot-proof, it is not enough to understand tech. It is not enough to understand what makes us unique as a human species. We will have to be constantly learning and relearning. And that's an enormous opportunity, not only for universities, but for every human being. That's why I think we are at a transition point. Either we become obsolete or we thrive as human beings. And in order to thrive, we constantly need to be ahead of the machines, and we constantly need to think what makes us unique. And the machines are getting smarter, so we have to become ever more relevant. And that's the opportunity of a partnership with universities. And that's a wake-up call for universities. Which means that now even universities have to go outside the realm of their campuses and be there wherever the learner is. And you are going to see the onset, the beginning of global university systems. For instance, at my university at Northeastern, we have opened campuses for lifelong learners in Seattle, in Silicon Valley, in Charlotte, in Toronto, and soon we will be in Latin America, and soon we will be in Asia and Europe. Why? Because we have to be where the learner is. So we are at a transition point. Jobs will disappear, but other jobs will start. That's an enormous opportunity for every human being to be engaged in lifelong learning, and it's an enormous opportunity for universities to be the provider of lifelong learning. If we don't do it, we risk becoming obsolete. If we do it, the opportunities are limitless. So I'm going to show you now a little video about summarizing a little bit of what we are trying to do at Northeastern University. Let's play the video, please.